Good morning, students. Today we'll be continuing our second QA session, and in which I'll be giving one by one questions. You please open your notebook. Please do these solutions along with me. At any step during that computation, if you have any smallest questions, please feel free to me, and we will discuss and proceed further. So you'll get the first question in another few seconds. Just a formality, could you please confirm that you are able to hear my voice clearly and able to view the screen properly?
Yes, sir.
Okay, thank you. Yeah, the first question, what you see is that the three distinct...
And I can't see the screen.
Okay.
Yes, the screen is not shown.
Okay, yeah. I hope you'll able to view it now.
Yes.
Okay, great.
Yes, sir.
Okay, the question is that the three distinct points, AT1 square 281, B is AT2 square 282, and C is 0, A, where A is a real number, are collinear if any, what is the following four options, that which one has to be satisfied. So let me do this, perform this solution slowly. You can also do, and if you know how to do it, you can do it faster than me, whatever, because I need to explain to everyone. So we know the 3 points are collinear if the value of this particular determinant is 0. You recall that coefficient of x, y, and the constant term has to be 0. So that means the condition for collinearity is that the value of this determinant, what is the value of the determinant? AT1 square 2A-T1 and 1 AT2 square 282 1 AT2 square 282 1 and 0A1 0A1, this value has to be 0. The value of this determinant has to be 0. Now, dear students, is that from here we need to find the condition, means find which one of the following four options are correct. Now, I would like to explain you something. You know how to compute the value of a 2x2 determinant, that I hope you are aware of. That if you have a determinant something like this, A, B, C, D, then you know that its value is that A into D minus B into C. But there are some properties of determinants also. I'm just informing you, and later when we discuss determinants, we'll discuss in details. It says that we can take an element common from any single row or any single column. That means what? We can take that A common from the first column, then the entire determinant will be multiplied by that number. That means we can take A common, and the first column become T1 square, T2 square, and 0. And second column become 2A-T1, 2A-T2, 1, because we took A common, and last column is 1, 1, 1, and this should be equal to 0. Now further we can take A common from the second column. So if we take A common from the second column, then what we'll get? We'll get A square, correct? T1 square, T2 square, 0, then T1, 2T1, 2T2, I'm sorry, I made a mistake here. It should not be 1, it should be A, because we took A common from the first column, second column will remain unchanged. Here it will be 1, and 1, 1, 1, This should be equal to 0. Correct, dear students? Now, we can expand this determinant with respect to the first row. Okay. So then what we are going to get? We are going to get is something like that. A square cannot be 0. So definitely the value of this determinant is going to be 0. That means t1 square 2t1 1 t2 square 2t2 1 0 1 1, that has to be 0. Okay. Now what we can do is that we can expand the determinant with respect to the third row also, because it has a 0. So and at the same time, as you are new to the determinant, so let me do it with respect to the first row. Okay. Once we are comfortable with determinant, we can use some other properties to so that our computation is reduced. So what we can do is that is t1 square. If you recall, it should be the 2 by 2 determinant, 2t2 1 1 1. Then minus 2t1, it is t2 square 1 0 1, and plus 1 is that t2 square 2t2 0 and 1. That has to be equal to 0. So now let's compute this thing. That t1 square is equal into 2 t2 minus 1. So t1 square into 2 t2 minus 1 minus 2 t1 into t2 square minus 0 minus 2 t1 into t2 square minus 0 plus t2 square minus 0 into 2t2. So that is here it is 1 into t2 square minus 0 into 2t2 is equal to 0. So from here what we get is that 2t1 square t2. So 2t1 square t2 minus t1 square minus t1 square minus 2t1 into t2 square plus t2 square is equal to 0. So what we can take common? We can take 2t1 t2 common from the first and third term. So if we take 2t1 and t2 common, so we get t1 minus t2 and minus of t1 square minus t2 square, so it will become t1 plus t2 into t1 minus t2, that is equal to 0. So we can take t1 minus t2 common. So from here what we can write? T1 minus t2 common into 2t1 t2 minus t1 minus t2 is equal to 0. This implies what? This implies either t1 equal to t2, either t1 equal to t2, or 2t1 t2 is equal to t1 plus t2. If t1 equal to t2, then the value of the determinant is obviously 0. Because there is a property called, if any two rows or any two columns of a determinant are equal, then the value of the determinant is 0. So the most Favorable solution is the 2T1 T2 is equal to T1 plus T2, and which is also there in one of the options. T1 equal to T2 is a very obvious solution, hence it is not there given. It is not given in any of these options. Okay, so this is the way we can find the solution. Correct, dear students? So now we can proceed for the next one. Second question, dear students. The question is that if the distance between 2, 3 and minus 5, 2 is equal to the distance between x, 2 and 1, 3, then find the value of x. Okay, so let's see how to solve this question. So according to the question, what you can find out is something like this. The distance between the point 2, 3 and minus 5, 2, so that should be square root of minus 5 minus 2 whole square plus 2 minus 3 whole square, that is equal to square root of 1 minus x whole square plus 3 minus 2 whole square. Correct? Now we can make a square of both the sides. So if we make a square of both the sides, so that becomes 49 plus 1 in the left hand side, and right hand side we get x minus 1 whole square plus 1, x minus 1 whole square plus 1. So from here what we get is that x minus 1 whole square is equal to 49. That implies x minus 1 is equal to plus minus 7. Correct? So now if we consider the plus 7, then x minus 1 is equal to 7, and from here we get x is equal to 8. And if we consider x minus 1 is equal to minus 7, then we get x is equal to minus 6. So minus 6 and 8 are the solution, and hence we get the correct option as option A. It's quite simple question. It's not difficult at all. I hope all of you got it.
Yes.
Yeah. The next question, dear students, is that here, if the 3 points, as you see in the question it is mentioned, if the 3 points 0, 1, 0, minus 1 and x, 0 are vertices of an equilateral triangle, then we need to find the value of x. So now as these 3 points are the vertices of an equilateral triangle, so if we name these 3 points as ABC, then what we are going to get, dear students? Suppose we give this point A as 0, 1, B as 0, minus 1, and C as x, 0. Now, as it is equilateral triangle, definitely AB should be equal to BC, correct? From here, what we can say, AB is equal to BC. And if we find AB equal to BC, this implies AB is equal to what? Square root of, 0 minus 0 whole square plus minus 1 minus 1 whole square. That is equal to square root of, x minus 0 whole square plus 0 minus minus 1. That means 0 plus 1 whole square. Correct? So from here what we get, minus 1, that is minus 2 whole square is 4. That is equal to square root of x square plus 1. Correct? So from here what we can say is that, we should remove that square root. So it should become x square plus 1. So from here we get x square is equal to 3, and eventually we get the value of x is equal to plus minus square root 3. And we get the solution as option B, root 3 and minus root 3. Okay, so these are very simple questions. So I think we should proceed to the next question. So here the question is that, and that question number 4, dear students, which is in front of you, is that if C is a point on the line segment joining A, coordinate minus 3, 4, and B, coordinate 2, 1, such that AC is equal to 2BC, AC is equal to 2BC, then the coordinate of C is what we need to find. Okay. So for that, what you need to do is that as we know the distance formula, we should leverage the distance formula here, dear students. So to proceed on that, what you should do first, we can use distance formula. Also, there is another approach you can think of, that let's first give a visual representation of this problem. So AC is equal to 2 into BC. So if we draw the straight line, suppose this is the point A, this is the point C, and this is the point B. What is the coordinate of the point B? It is minus 3, 4. And what is the coordinate of the point A? Is coordinate of the point A is minus 3, 4, and coordinate of the point B is 2, 1. And according to the question, AC is equal to 2 times of BC. Okay, so that means what? AC is to BC, we can write 2 is to 1. Correct, dear students? So I was telling to use, distance formula, but better than distance formula is to use the internal section formula. We need to find the coordinate of C, right? Let's assume the coordinate of the point CB alpha, beta. Now using that section, internal section formula, we can easily find the value of alpha and beta. As you know, dear students, so that 2 should be associated with the coordinates of the point B, and 1 should be associated with the coordinates of the point A. So from here, what we get the value of alpha? Alpha should be equal to 2 into 2 plus 1 into minus 3 divided by 2 plus 1. So from here, what we get? Alpha is equal to 4 minus 3, that is 1. It is 1 by 3. You don't need to perform any other solutions. As you get the value of alpha equal to 1 by 3, and X coordinate among these four options is only one option is there, 1/3. From there you can just apply your intuition and conclude that option A is correct. But for the sake of completeness, let's do find the value of beta. Beta should be what, dear students? Beta should be 2 into 1, that is the y coordinate of the point B, plus 1 into minus 1 into 4, that is the y coordinate of the point A, divided by 2 plus 1. So it becomes 2 plus 4, 6/3, that is 2. So it is matching. So the coordinate of the point A, coordinate of the point C becomes 1/3, 2, and eventually we get the correct option as option A. Now, dear students, let's proceed to the next question. Question number 5. Here the question number 5 says that, that if C is the reflection of A 2, 4 in x-axis and B is the reflection of C in y-axis, then we need to find the value of AB, that is the non-negative value of AB. The distance AB, we need to find it out, dear students. So how we can find it out? Let's see. So it is better to give a visual representation of this problem, dear students. Okay. And if we give a visual representation, let's see how the problem is actually, how it looks like. So if you look into the adjoining diagram, dear students, if you see the point A is having this coordinate 2, 4. Here is the point A in the first quadrant. First it gets reflected in the x-axis. Once it gets reflected in the x-axis, we get this point C, and obviously its x coordinate should remain the same 2, but y coordinate should be negative, -4, because of obvious reason. Okay. Now after that, the point C is getting reflected into the y-axis. Then it finally comes to the point B. So if it is the case, then what will happen? Its y coordinate will remain the same, that is -4, and x coordinate will become -2, because for the point C, x coordinate was 2, and for the point B, which is reflected on the y-axis, definitely will have the x coordinate negated, that is -2. Y coordinate will remain the same, -4 in both the cases. So we got 2 points, A with coordinate 2, 4, and the point B with 2, by -2, -4. So all you need to do is to find the value of that length AB. It is quite simple, dear students. But first, visualization was important. So square root of AB should be x coordinate of the point B, that is -2, minus x coordinate of the point A, that is -2 whole square, plus y coordinate of the point B, that is -4, minus y coordinate of the point A, that is 4, but activated -4 because minus of x coordinate of the y coordinate of the point A. So that becomes what? Square root of 16 plus 64. 16 plus 64 is equal to square root of 80, and square root of 80 is actually coming as a 4 root 5. And eventually we get the correct option as option C. Okay, dear students, so let's proceed to the next question. So as you see the question number 6, he said that the point on the line 3x plus 4y equal to 5, which is equidistant from 1, 2 and 3, 4 is what? We need to find it out. So how to proceed in this question, dear students? That it is equidistance. So if we apply, this one, first let's take the point on the line 3x plus 4y equal to 5 is a point x1, y1. Okay. Now, suppose this is a straight line. On this straight line, so this is the equation of this straight line. I mean, as you see that 3x plus 4y is equal to 5. Now, a point on this one, suppose there is a point P with coordinate x1, y1, and it is equidistant from both the point. Suppose there is a point A with coordinate 1, 2. Okay, and there is a point B, the point B with coordinate 3, 4. So that means what? AP is equal to PB. And what we need to find? We need to find the value of that coordinate of the point P, that is x1, y1. Now, as AP is equal to PB, what we can write is that AP square is equal to PB square, dear students. Correct? So, AP square is equal to PB square. Now, what is AP square? x1 minus 1 whole square plus y1 minus 2 whole square is equal to PB square, x1 minus 3 whole square plus y1 minus 4 whole square. Now, let's simplify this equation. If we simplify this equation, what we get in the left hand side? X1 square minus 2x1 plus 1 plus y1 square minus 4 into y1 plus 4 is equal to x1 square minus 6 into x1 plus 9 plus y1 square minus 8 into y1 plus 16. So x1 square, y1 square, x1 square, y1 square in the left hand side and right hand side got cancelled. And then finally what we'll get is that, 4x1 plus 4y1 is equal to 20. So that implies what? That implies x1 plus y1 is equal to 5. So let's give this equation number 1. Now, dear students, the point P, whose coordinate is x1, y1, is also on the straight line 3x plus 4y equal to 5. So it must satisfy this equation. 3x1 plus 4y1 is equal to 5. Correct? Now, we need to solve these two equations. Solving these two equations are pretty simple. So what we should do, equation 2 minus 4 times of the equation 1. Then what we'll get? Equation 2 is that 3x1 plus 4y1 minus 4x1 minus 4y1, that is equal to, equation 2 is 5 minus 4 into 5 is 20. So 4y1 got cancelled. So from here what we get is that minus x1 is equal to minus 15. So from here we get x1 is equal to 15. Correct? The moment we get x1 is equal to 15, we can then from equation 1, what we can say is that y1 is equal to 5 minus x1. That implies y is equal to 5 minus 15. That implies y1 is equal to minus 10. So the coordinates of the point P is 15 comma minus 10, and eventually we get the correct option as option B, dear students. I hope it is clearly understood. Now let's go to the next question. So question number 7 in front of you, dear students. It says that, if A with coordinate k comma 2 and B with coordinate 3 comma 5 are points, and the point T comma T, a point T comma T is there, divides the line segment AB from A side in the ratio of k. In the ratio of k means it is actually implicit. The meaning is the ratio of k is to 1. Then we need to find the value of k. Correct? So if we give a visual representation of this problem, dear students, so suppose this is the line segment AB. This is the point A. This is the point B. Now, and coordinate of the point A is k comma 2, and coordinate of the point B is 3 comma 5, and the point, point T comma T. So let's take that point C having coordinate T comma T, divides that line segment AB from A side in the ratio k. That means AC is to CB is k is to 1. Correct? And we need to find the value of k. Properly we can use that section formula. So k should be associated with the coordinates of the point B, and 1 should be associated with coordinates of the point A. And we can find the x coordinate of the point C, that is T, means I can write explicitly that x coordinates of the point C, that is equal to what? That is equal to x, that is equal to, so not x, sorry, t. This implies what? How we can find the value of t? T should be k into x coordinate of the point B, that is 3, plus 1 into x coordinate of the point A, that is k, divided by k plus 1. So from here we get the value of t is equal to 3k plus k, 4k by k plus 1. 4k divided by k plus 1. Let's keep that equation number 1. Now in the similar manner, the y coordinates of the point C, y coordinates of the point C, that is also T. So from here what you can say is that T is equal to K into y coordinate of the point B, that is 5, plus 1 into y coordinate of the point A, that is 2, divided by K plus 1. This implies what? This implies T is equal to 5K plus 2 divided by K plus 1. This we get equation number 2. So now from equation 1 and 2, what we get is that 4K is equal to 5K plus 2, correct or not? So let's take equation 1 and equation 2 together. Both are 2, no? So 4K divided by K plus 1 is equal to 5K plus 2 divided by K plus 1. So this implies 4K minus 5K is equal to 2. 4K is equal to 5K plus 2. Since K plus 1 cannot be equal to 0, it is quite obvious that K plus 1 cannot be 0. If K plus 1 is 0, then the question doesn't make sense. That implies what? K is equal to minus 2. And eventually we get the correct option as option B. Any doubt, please do let me know, dear students. Now the next question I'll go. The question number 8 says that the point Q is symmetric to the point P whose coordinate is given as 4, minus 1. Okay. And the next statement, what it is saying is that, with 4, minus 1, with respect to the bisector of the first quadrant. Okay, the point Q is symmetric to the point 4, minus 1 with respect to the bisector of the first quadrant. Now we need to find the length of PQ. So let's give an visual representation of this problem. Okay, so if you give a visual representation, so it's something like this. As you see, dear students, now this coordinate of the point P is 4, minus 1. Now the point Q is symmetric with respect to, point Q is symmetric to point P with respect to the bisector of the first quadrant. So bisector of the first quadrant is this one. This straight line is the bisector of the first quadrant. Okay. But then how to find this one? Okay. There are multiple ways we can do it. But one way we can say is that first we need to find what is the equation of the bisector of the first quadrant. Bisector of the first quadrant is nothing but a straight line passing through the origin, makes an angle 45 degree with the positive direction of the x-axis. So this angle is 45 degree. Correct or not? So what will be its equation? Its equation will be y is equal to tan 45 degree into x. Correct or not? Its equation should be y is equal to tan of 45 degree into x. That implies y is equal to x. That implies x minus y is equal to 0. And this is the one equation, as you see. Now, as the point Q is symmetric with respect symmetric to point P 4, minus 1 with respect to the straight line x minus y, 0, then if we get a point Q that is which is symmetric to the point P with respect to the straight line x minus y, 0, then definitely PQ should be equal to 2 into PP dash. Correct or not? We need to find the value of PQ. So definitely PQ should be 2 into 2 times P into P dash. What is P into P dash? P into P dash is nothing but the perpendicular distance from the point 4, minus 1 to the straight line x minus y equal to 0. So that means this is equal to 2 times mod of 4 into 1 minus 1 into minus 1 divided by square root of 1 square plus 1 square. Correct? So that becomes 2 into 4 minus of minus 1, that is 5. So 5 by 2 into 5 by root 2. So from here what we can get is that PQ is equal to 2 into 5 by root 2. That implies PQ is equal to 5 root 2. And eventually we get the correct option as option B. Now let's look into the next question, dear students. The question here is that, question number 9, dear students. There are 3 points given, that is, coordinate of the point P, as you see, that minus of sine beta minus alpha minus cos beta. Coordinate of the point Q is cos of beta minus alpha, sine beta. And coordinate of the point R is cos of beta minus alpha plus theta and sine beta minus theta. And we see that alpha, beta, theta in between 0 and pi by 4. Then we need to conclude that which one among them is true. Now for that, dear students, so what we can do is that we can find the value of this, the determinants. Okay, that if the value of the determinant is not equal to 0, then we conclude that it is a that these 3 points are not collinear. So what is that the value of the determinant? Minus of sine beta minus alpha minus cos beta 1, then cos of beta minus alpha sine beta 1, and cos of beta minus alpha plus theta and sine of beta minus theta 1 if you find the value of this determinant, you will see this value of this determinant is not equal to 0. Okay. This value of this determinant cannot be equal to 0. You can expand it and you can find it out. So directly we can conclude, the points are non-collinear. For any value of theta, alpha, beta, theta between 0 to pi by 4, the value of this determinant cannot be equal to 0. So the points are non-collinear and eventually we get the correct option as option D. Correct, not students? Got it?
Yes, sir.
Okay. Now, next question I'm going to do. Okay, the question here is that what is that one possible condition for the 3 points whose coordinates are given, as the a comma b, b comma a, and a square comma minus b square to be collinear. We know what is the condition of collinear, that the value of the corresponding determinant has to be equal to 0. So that is, it will be a b1, then ba1, and then a square minus b square 1, a square minus b square 1. The value of this determinant has to be equal to 0. Now to compute this value of this determinant, it will take little time based on whatever the knowledge you have at this present student. So I'm just going to give you one little knowledge about the determinants. Okay. So for example, today we learned one thing about that we can take if we take one element common from any row or column, then the entire determinant is multiplied by that number. That we have done in one of the questions. So here we are going to learn something new. Okay, what is that? That if we make any row or any column, multiplied with the corresponding element of any other row, the value of the determinants will remain unchanged. So what does it mean, dear students? It means is that from this determinant, I can make an operation. So I'll write the determinant first, hollow determinant. So I'm not writing the elements here. That is equal to 0. But what operation I'm going to do is that my new R2 is the old R2 minus R1. That means my R1 and R3 will remain the same as they are in the previous determinant. That is AB1, A square minus B square 1. But the second row elements would be the earlier second row minus row 1. That means B minus A. It will be A minus B, and 1 minus 1 is 0. Correct? Got it? Now, the moment it is there, what we can do is that we can perform another operations. And the next operation, what we are going to perform, dear students. So let's write that first the hollow determinants. And we are going to write R3 is R3 minus R1. That is equal to 0. So my new R3 is the old R3 minus R1. So here R1 and R2 will remain the same. That is A, B1, B minus A minus B, 0, A square minus B square 1. Sorry, this will get changed, my mistake. R3 will get changed. R3 will be what? A square minus A. It will be A square minus A. It will be B square minus B. And then 1 minus 1 is 0. Now, what we can do is that we can expand the determinant with respect to the third column. You know why? Because we should always expand the determinant with respect to that row or that column which is having maximum number of zeros. So here we are going to expand the determinants with respect to the third column. So if we do this thing, so then what we are going to get is that determinant of b minus a into a minus b divided by a square minus a into b square minus b is equal to 0. Okay, now let's look into it. What you need to prove, that what condition is satisfying. Okay, so now we learned today one thing is that we can take an element, if one element is common to any of the row or column, then we can take it that element common and the entire determinant is get multiplied. That means if we take a minus b here, then the determinant will be minus 1 1 a square minus a and b square minus b, that is equal to 0. Correct? So now from here what we can get, dear students, from here we get a minus b into, here we will get minus b square, here we will get that b minus b square minus a square plus a is equal to 0. And from here what we get is that okay, just a minute. Yes, okay, just there's a small mistake I have done. That is minus b square, na? So it should be minus b square here, minus b square here. So it should be minus b square into minus 1, so b plus b square. Okay, b plus b square minus a square plus a. So now already we can again take a plus b common. So from here what we can write is that this implies a minus b into a plus b square minus a square, b square minus a square, that is equal to b minus a into b plus a is equal to 0. This implies a minus b into a plus b into 1 plus b minus a, that is equal to 0. Correct? So that implies either a minus b is equal to 0 or a plus b is equal to 0 or b plus 1 minus a is equal to 0. This implies either a minus b equal to 0 or a plus b equal to 0 or 1 plus b minus a equal to 0. Now let's see which option is given. What among these options is given is that a is equal to 1 plus b or a is equal to 1 plus b is the correct option here, and we get that option C is the correct one, dear students. So we get a is equal to 1 plus b from here. So this implies a is equal to 1 plus b, and eventually we get the correct option as option C. Okay, dear students, so we have done solution to the 10 questions. So our next class is on Monday, and we will discuss some more questions from this topic. Thank you very much.